Up to this point, we have just focused on real numbers. This video, we're going to introduce complex numbers. A complex number is simply a number that contains real number and an imaginary number. This video is going to focus on introducing imaginary numbers. So as we get started here, if we were to take the square root of 4, we know that the square root of 4 would simply be equal to 2. And we know that if we tried to take the square root of a negative 4, that would be undefined, or more specifically, it would be not a real number. And we know that if we take the square root of 1, that is equal to 1. Well, now we're going to define the square root of a negative 1. And again, this is going to be defined as I. So this is representing our imaginary number. So now anytime that you see the square root of a negative 1, we can simplify that to simply I. So over here, when we have the square root of a negative 4, we can think of this as the square root of a negative 1 multiplied by 4. And we can pull this out as the square root of a negative 1 would be I, and the square root of 4 we know is 2. So therefore, the square root of a negative 4 is simply 2i. So anytime you're taking the square root of a negative number, you're always going to pull out the negative as representing the I, which is the imaginary part. So over here, we're going to go through and define some of this. We know that if we have I, that is simply going to be equal to I. We're not going to be able to simplify that because keep in mind here, I is representing the square root of a negative 1. Now, what happens if we square I? If we have I squared? Well, that means, for example, we're going to take the square root of a negative 1. We know that that is defined to be equal to I. If we were to square both sides of this equation, then the square and the square root will cancel each other out, and we're left with a negative 1 is equal to I squared. So therefore, anytime you see I squared is going to be defined as a negative 1. So we can simplify I squared to equal negative 1. Well, what happens if we take I cubed? Well, I cubed, that would be the same thing as if we were to take I times I squared. Well, if we were to take I times I squared, what does that equal? Well, we know that I is simply equal to I, and we know that I squared is equal to a negative 1. So I times a negative 1 would equal a negative I. So I cubed reduces to a negative I. And then we're going to look at I to the fourth. If we take I raised to the fourth power, and there's a couple ways we can look at this. I to the fourth, we could think of I to the fourth as simply being I squared times I squared, because when we multiply, we add exponents. Well, we know I squared is equal to a negative 1. So that means we would have negative 1 times negative 1, and negative 1 multiplied by negative 1 is a positive 1. So if you have I to the fourth power, we can simplify that to a positive 1. Now, if we were to continue through this process, and if I was to raise this then I to the fifth power, or I to the sixth, I to the seventh, or I to the eighth, what you're going to find out is if you had I to the fifth, that means you could take I times I to the fourth. Well, that means you would have I multiplied by 1, which is equal to I. So I to the fifth simply equals I. Now, we could go through each one of these, but you're going to notice that this pattern is going to repeat. I to the sixth is going to be negative 1, I to the seventh is negative I, and I to the eighth is 1. So if you notice here, every 4, they're going to repeat. So when you go from I to the fourth, it's I negative 1, negative I 1. And then from I to the fifth, I to the eighth, again, it's I negative 1, negative I, positive 1. And then that pattern would keep on repeating. So knowing that pattern really makes it easy to calculate I raised to a power. For an example, if we were to take and take I raised to the 22nd power. Then because this repeats every 4, we can take 4 and divide that into the exponent 22. How many times does 4 go into 22? Well, 4 will go into 22 5 times, and we are left over with a remainder of 2. This here is representing our exponent. Well, if we go up here, we have I squared. I squared is equal to a negative 1. So that means that I to the 22nd power equals a negative 1. So if we had a remainder of 3, you would go here, I cubed. The remainder of 3 would tell us it would be equal to a negative I. And if it divides evenly, for example, if you had I to the 16th power, we would take 4 and divide that into 16. And of course, that's going to divide evenly. If you get a remainder of 0, then that means it's going to be equal to a positive 1. So that's how you can easily do that. Now, you actually have this I button on your calculator. Okay, if you look on the TI-83 or 84 calculator, at the very bottom of the screen where your decimal point is, you're going to see above that decimal point the letter I. And to access that, you can just simply hit second function in the decimal point, and you should see on the calculator I. So if you hit second function decimal point, and then you can hit your little caret key for your exponent, and if you square it or cube it, if you square it on the calculator, you should get an answer of negative 1. Or if you raise it to the third power, the calculator is going to give you an answer of a negative I. Okay, so your calculator will actually do those operations for you as well. But it's good to know how to perform these calculations by hand. All right, for an example, let's see if we can simplify some of these numbers. If I was to give you, let's say, the square root of a negative 36, what does this equal? All right, now, to do this, we could take and think of this as the square root of a negative 1 multiplied by 36. Well, we know that the square root of 36 is equal to 6, and the square root of a negative 1 is equal to I. So the answer would be 6I. And if we had, let's say, the square root of a negative 12, well, we could again think of this as the square root. The negative is simply the square root of a negative 1. And then the number 12 is not a perfect square, but we could think of that as 4 times 3. And now we have the square root of 4, which is 2. The square root of a negative 1 is I. And then the 3 we have to leave underneath the square root. So the answer is 2I square root of 3. Now, notation-wise, I want to point this out. I prefer anytime that I have a square root as part of my answer, I will put the I in front of the square root, just like I put the number 2 in front of the square root. If you look on your quizzes or your test or in a lot of your math textbooks, you're going to notice they would write the answer as 2 square root of 3I. Now, sometimes to me, this looks a little confusing because sometimes it looks like this I is underneath the square root, but it is not under there. But sometimes the books put it really close to the square root, and to me it looks a little confusing. So you'll notice that when I write this, I will take the I and simply have it in front. So either way is correct, but realize here that this I is not underneath of the square root. All right, another example. We have, let's say, the square root of a negative 21. How can we simplify this? Well, the only thing we could do here is think of this as really the square root of a negative 1 times 21, because 21 we cannot break down as a perfect square. So the only thing we can do here is actually take the square root of a negative 1, which is simply I, and then you're left with the square root of 21. All right, now what happens if we have the decimal? If we take the, say, the square root of a negative 12.25. Well, once again, mentally, you can think of this as square root of a negative 1 times 12.25. And you could certainly take the square root of 12.25, put that into the calculator, and you would find out you would end up with 3.5. And of course, the square root of a negative 1 again is simply I. So hopefully you can see that anytime that you have a negative here under the square root, your answer is going to turn out with basically just an I when you take the square root of the negative. All right, now let's look at an example, let's say going the other direction. What happens instead of taking the square root? What happens if we were to square something like 7i squared? Well, of course, that means we have to square the 7. So 7 times 7 is 49. And then, of course, I would be I squared. Now, you can basically think of treating I similar to a variable, but here we can simplify I squared. We could actually write this as I squared. Remember, what does that equal? And this is something up here you really would want to memorize these first four. If you have I squared, we know that I squared is equal to a negative 1. So here, we don't want to leave the answer as 49i squared. We would write it as 49, and you can think of this as 49 times a negative 1, or just simply write negative 49. All right, so what if we had, let's say, 2i raised to the fifth power? Well, that means we would have 2 to the fifth, and that means you're going to multiply 2 5 times, so that's going to be 32i to the fifth. And once again, we need to simplify I to the fifth. So how would we do that? Well, remember, I to the fourth is equal to 1. And then if you want to multiply that by I, you'd have 1 times I. So that would simply be 32I. Okay. Now, once again, you could put this into the calculator. If doing so, if you want to take I to the fifth power, you could certainly hit second function, your decimal point, and then your exponent key raised to the fifth power, and the calculator would give you the I. All right, now one thing I do want to point out here, as far as using the calculator, be careful with. If we had the example, let's say I raised to the 22nd power, and this is the example we did earlier, we know that up here we said I to the 22nd power equals a negative 1. Now, I do want to point out, if we use the calculator here, if you hit second function and I raised to the 22nd power, notice on the calculator, it's going to give you an answer of negative 1 minus 2e, and then it has a negative 13i. Now, what this is doing is this is basically saying we have a negative 1, and I'm going to rewrite this. This is basically the calculator giving you scientific notation. So this is really representing negative 1 minus, and then this part is scientific notation. The 2e to the negative 13 really means 2 times 10 to the negative 13th power. Now, for example, if I was to give you the number 2 times 10 to the negative 13, what does this mean as far as scientific notation? Well, this means that your decimal point is here on the 2. The negative 13 says we need to move the decimal point 13 places to the left. Well, that means you're going to have basically a decimal point, 12 zeros, and a 2. So this number here is essentially 0. So then all of this here is equal to 0. Now, I'm really not sure why the calculator does this, but every now and then you'll see something where you have a number with e to the negative 13 or 14 or 15. Basically, that number is so small, for some reason your calculator gives you the scientific notation, but this number here is really 0i, which if you have 0i, that means it's 0. So therefore, your answer is out front here simply a negative 1. So I to the 22nd power is a negative 1. So be careful if you see, again, this on your calculator, it's a possibility that that is actually just simply equal to 0. Now be careful. Make sure that this sign here is negative and this number here is rather large, like 13 or so. Now, if this was just a negative 2 here, then that means you're only going to move the decimal 2 places. So that would be 0.02. But if this number is really large, you know that it's going to be equal to 0. So just be careful with the answer that the calculator gives you. So as a review from this video, make sure that you understand up here I equals I squared equals negative 1, I cubed is negative I, and I to the fourth is equal to 1. So anytime you're simplifying an expression and you have something greater than I, you want to make sure that you reduce it to either negative 1, negative I, or a positive 1.